So below here is all the questions from last week's practice MCAS exams that we did that as a whole class we struggled with. So the first one is number 3. The students in a science club planted a rectangular flower garden in front of their school. The garden is 6 feet wide and has a diagonal length of 10 feet, and it's asking us to find x. Now, just like in the warm-up, remember the Pythagorean theorem. A squared plus b squared is equal to c squared. Right here, this is a right triangle. It has a 90-degree angle, which means that we can use the Pythagorean theorem. So, I zoom in here. I know that we have a squared plus b squared is equal to c squared. If I make a equal to 6, b equal to x, and then c in this case would be 10 feet because c is always across from that right angle. So if I fill in our missing side lengths, I have 6 and it needs to be squared, plus I'm going to change b for x squared is equal to 10 squared. Now 6 squared is 36. We're going to keep the x squared, and 10 squared is equal to 100. So now I need to solve for x. So I can start by taking away 36 from each side. So that cancels, and I'm left with x squared is equal to 100 minus 36, which is 64. Now, we need to find the square root of each side because I'm not looking for x squared. I'm looking for just x. So if I take the square root of each side, x squared becomes x. And I know that 8 times 8 is equal to 64. So 8 would be the square root of 64. So our missing side length is that x is equal to 8, which is b. Okay. The next one is, what is the decimal equivalent of 5/6? And it says to round our answer to 3 decimal places. Now, if we remember our conversions, if we're going from a fraction to a decimal, we divide the numerator by the denominator. So, if we remember our long division, the top hops into the box. So if I go back up here, since we have 5/6, that is the same thing as 5 divided by 6. If we do the math out, 6 does not go into 5, so I'm putting 0 as a placeholder. And remember, I can add as many zeros after I put in a decimal place. So now my question is, how many times does 6 go into 50? And that would be 8 times, because 6 times 8 is equal to 48. And I can subtract 50 from 48 to get 2. And I can bring this 0 down to make it 20. How many times does 6 go into 20? That would be 3 times. 6 times 3 is 18. Subtract 20 and 18 to get 2 again. I can add another 0 and bring it down. 6 goes into 20 3 times, which is 18. And now I can see I'm going to keep following this pattern of getting 3s because I keep getting 20 left over. So, the decimal equivalent to 5/6 to 3 decimal places is 0.833. So if we look at our next problem, It says, which of the following represents a linear relationship with the greatest rate of change? Now remember, rate of change is slope. So if I look at A here, this is y is equal to mx plus b, and remember m is equal to our slope. So for A, our rate of change would be 2. Now if I look at B, I'm looking to see how we're getting our y's, because if I look at my x's, they're going up by 1, so I want to know what happens here. So to get from negative 13 to negative 8, I'm going to add 5, because negative 13 plus 5 is equal to negative 8. If I look from negative 8 to negative 3, again it's plus 5, and so on. They are all plus 5, which means that my rate of change here is equal to 5. So far, B is in the lead, so I know it can't be A. So let's see. C says line rises 9 units for every 3 units it moves to the right. So remember, slope is also rise over run. So in this case for C, we would have it rises up 9 for every 3 to the right. 9 over 3 is the same thing as 3. So I know C is not my answer. And for D, again, we can do rise over run. If I pick 2 perfect spots, so let's see, here's a perfect spot, and so is right here. If I do my rise over run, I'm going up 1, 2, 3, 4 spots here, and I'm running over once. So my slope here would be 4 over 1, which is just equal to 4. So if I zoom back out, I can see that B is the correct answer because it has the greatest slope, which is 5. Now, for this question right here, number 1, part A, it says the line passes through the points 3, 5, and 2, 0. So if we don't have a graph or a table or something to find out what the slope is for rise over run, we can use the slope formula. M is equal to y2 over y2 minus y1 all over x2 minus x1. So if I look at this question here, I can label my points x1, y1, x2, y2. So again, M is equal to y2 minus y1 over x2 minus x1. So if I fill this in, I would have 0 minus 5 all over 2 minus 3. 0 minus 5 is a negative 5, and 2 minus 3 is a negative 1. So we have negative 5 over negative 1. Now remember, if we have a negative number divided by a negative, it changes to a positive. So this is really 5 over 1. And 5 over 1 is just equal to 5. So my slope here would be B. M is equal to 5. For our next question, we're back at the Pythagorean theorem. It's asking what is the hypotenuse of the figure shown below. Again, remember we know it's a squared plus b squared is equal to c squared. C is always across from our 90-degree angle, so C is going to be x. in this case, and then I'll label this A and this B. So I have 30 squared plus 40 squared is equal to x squared. 30 times 30 is 900. And 40 times 40 is 1600, which is equal to x squared. Now I can add the 900 and the 1600 to get 2500 is equal to x squared. Now remember, I need to take the square root of both sides. And this is where you'll want to use your calculator if you can, because you won't know these numbers in your head. So let's see, if I plug this in, I need the square root of 2500, which is equal to 50. And the square root of x squared is just x. So in this case, our answer is A, 50 yards. And for part B, it says, a different rectangle has a diagonal of 60 yards and a height of 40. So, if I draw this out, this diagonal right here is 60, and the width is 40. So we are looking for the side length. So again, we can set that as A, this is B, and this is C. So I have x squared plus 40 squared is equal to 60 squared. $40 squared we already know is 1600, and 60 squared is equal to 3600. So I can subtract 1600 from each side to get x squared is equal to 2000. And I need to take the square root of each side. Which, in this case, let me back out a little bit. The square root of 2000 is approximately 44.721. But let's see. The problem says round the rectangle to the nearest hundredth. So that would be 44.72. So I'll put that here. Okay. For our next question, it's another two-parter. I have, Tim has $20 to buy snacks for 12 people in the office. Each person will get one snack, and Tim is buying bags of pretzels that cost $1.50 per bag, and bags of crackers that cost $2 per bag. So part A is asking, Tim is buying X bags of pretzels and Y bags of crackers. Which system of equations can be used to find the value of X and Y? Okay, so if we have X for pretzels and Y for crackers, and we know he's buying for 12 people, I know that X plus Y needs to be equal to 12. So if I look, that already crosses off A and B. We also know that pretzels are $1.50. So I'm going to have $1.50 for X, plus we know that bags of crackers cost $2, and that is Y. I also know that Tim only has $20. So the amount of money he spends has to be either equal to 20 or less than. So that would be 1.5x plus 2y is equal to 20, which would give us the answer of C. For part B, it says, how many bags of pretzels does Tim buy? So that means we need to solve for X. So there's a few different ways we can do elimination, substitution, to solve these. So there's nothing easy to eliminate. I am going to rearrange our top equation so that we have y is equal to 12 minus x. So I just subtracted x from each side. And I'm going to replace that into our second equation. So I have 1.5x plus 2y, and I'm replacing y with 12 minus x is equal to 20. I keep my 1.5x, and I need to distribute this 2 through to everything inside of the parentheses. 2 times 12 is 24, and 2 times a negative x is a negative 2x. And we have it's all equal to 20. Now I can combine my like terms, which is 1.5x and minus 2x, which would give us a negative 0.5x plus 24 is equal to 20. If I keep solving, I'm subtracting 24 from each side. So I have a negative 0.5x is equal to a negative 4. And I'm going to rewrite this over here so I have some more space. To get x by itself, I need to divide by a negative 0.5 on both sides. That way my x is alone. And I can divide a negative by a negative, we know is a positive. And negative 4 divided by negative 0.5 is equal to 8. So I know that he bought 8 bags of pretzels. Okay, so number 6 here and the one below it, number 3, both go together. We have the cube root of 125. Now, square roots and cubed roots are slightly different. A square root of a number x is the number s such that s times s is equal to x, which I think we've all got under control now. But a cubed root is different. We're looking for a number times itself 3 times is equal to the number underneath that radicand. So I have 125 there, and we're looking for the cubed root. This is going to be equal to 5, because 5 times 5 times 5 is equal to 125. Same thing here, I have a little example. What's the cubed root of 64? It's equal to 4 because 4 times 4 times 4 is equal to 64. Now, mostly on MCAS, they're going to give you multiple choice. So if you have a hard time here, we're looking for what number times itself 3 times is equal to 120. So if I do this out, I could start with 4, because 4 is A. 4 times 4. Let me zoom in. So let's do, if we do 4 times 4 is equal to 16, and 16 times 4 is equal to 64. So that's for A. For B, 5 times 5 is equal to 25. And 25 times 5 is equal to 125. So right now B is closer. For C, 9 times 9 is 81. And 81 times 9 is equal to 729. And I'm not even going to bother with D because I know it's going to be even larger than 9 cubed. So I know 125 is the closest here to 120, which means that B is my answer. Okay, and then another question on the MCAS that a lot of us had trouble with is exponents. So it says simplify each expression and write your answer using a negative exponent. So do we remember our exponent rules here? So we have the product rule. When we have the same base, we can add the exponents. We have the quotient rule, is that when we're dividing two bases that are the same, we can subtract the exponents. We have negative exponents where you just flip it across the fraction part to make it either negative or positive, the opposite of whatever you started with. And we have the zero exponent rule, that anything to the 0th power is equal to 1. So if I go back up to here and zoom in, I have 7 to the negative 12th times 7 to the 5th. This is the same thing as 7 to the negative 12 plus 5. Negative 12 plus 5 is equal to 7 to the negative 7th. So this would be 7 to the negative 7th, and it asked us to use our answer in a negative exponent. So that's perfect. Now for number 2 here, we have 10 to the negative 10th times 10 to the 5th, which is the same thing as 10 to the negative 10th plus 5, which would give us 10 to the negative 5th. Again, it's a negative exponent as it asked for. For 3 and 4, we're using the quotient rule. So I subtract 3 to the 4th minus 6 gives me 3 to the negative 2nd power. Again, negative exponent because that's what it asked for. And then for 4, I have 8 to the 12th, and I'm subtracting 15 from it to get 8 to the negative 3rd. Make sure that it's the top number, subtraction sign, then the bottom exponent. Don't flip it around because you will get the wrong answers. Okay, and now we're almost to the end. It says, Jocinda determined that a diagonal of her laptop screen is 2 square roots of 42 inches long. What is the approximate length to the nearest inch of the diagonal of her laptop screen? So, let me zoom in. We know that the diagonal is 2 times the square root of 42. Now, square root of 42 does not give us a pretty number, but if I think of things around it, I know that 6 times 6 is equal to 36, and 7 times 7 is equal to 49. which 42 is in the middle of both of those numbers. So I would approximate this, or approximate the square root of 42 to be about 6.5. So if I'm approximating 2 times the square root of 42, that'd be 2 times 6.5, which would be equal to 13. So I would say that this is approximately 13 inches. And then for classwork, is just some more independent practice problems on those type of questions. Now, for number 19 here, don't get confused. It's asking us the length of TU, which is right here. Now, we can make a right triangle here to help us solve this problem. If I look from T to U, I can make a right triangle and solve here, make that C, because you know the side lengths of those red lines I just drew.